Example 2. The heights of 13-year-old students are normally distributed. 97.5% of them are above 131 centimeters and 2.5% are above 179 centimeters. Find the mean and standard deviation for the height distribution. We'll start by defining our random variable x to be the height of the students. Please pause this video and try this question on your own first. Let's begin by sketching the normal distribution with the information provided from the question. By the empirical rule, we're able to deduce that 131 as well as 179 are two standard deviations above and below the mean. Since we know that 95% of all values fall within two standard deviations of the mean, and so we can see here that our distribution is symmetrical. So in order to find the mean, we need to find the average of those 2 points. So we add 197 with 131, divide by 2, to get our mean value of 155. Finally, to find the standard deviation, I take the difference between those two values, and we're going to divide by 4, since between the values of 131 and 179, there are 4 standard deviations. That gives us 6 centimeters. Part B. A 13-year-old student is randomly chosen. What is the probability that their height lies between 143 centimeters and 191 centimeters? Again, pause this video and try this question on your own. So again, let's sketch the normal distribution curve with the data values that we already obtained from the previous question, as well as the new points here. So 143 is going to represent 1 standard deviation below the mean, where 191 is going to represent 3 standard deviations above the mean. So to find the probability between these two values, we can look to the left and to the right of that curve. So first, let's start by looking to the left of the curve. So if you look at this shaded area in the green here, what we know is that by the empirical rule, 99.7% of all values fall within 3 standard deviations of the mean. Since we're only looking on the right-hand side of the curve, sorry, I said left the first time, it's the right side, we take 99.7 and divide by 2. Then we're going to look to the left of the curve. So what percentage of data points fall within 1 standard deviation of the mean? That is going to be 68%. So we take 68, divide by 2, that gives us 34 to get what's on the left of the curve. Add those two together and we get a probability of 83.85%. So of course, the empirical rule is not going to be as precise as your graphing calculator. So we're going to learn how to use our GDC to find probabilities quickly using the built-in feature of the normal distribution. To access this, you're going to press second, followed by vars, get to the distributions menu, and then you're going to select normalCDF. For all of questions regarding normal distribution, we are always going to be using normalCDF. We do not use PDF. So if we go back and look at the question from the first example about Proud's jumping, let's check this out. So we were asked to find the probability that Proud's jumps land somewhere between 9.17 and 6.61 centimeters. So we're going to enter the lower bound as 6.19 and the upper bound as 6.61. Our mean was 6.4. Our standard deviation was 0.21. Enter all those values, press paste, and you'll go back to your regular calculation menu, and we get almost exact same value, 68%, but this time we get 68.3%, so a little bit more precise than the empirical rule. Okay. Now let's look at 2 other scenarios. So if you look at the image on the left here, this one is again from the example 1, Proud's jumping. We're asked to find the probability that the distribution is less than or equal to 5.98%. So our mean and standard deviation values stay the same, but this time we're going to change our lower bound to some really, really small negative number. And that's because our calculator does not allow us to input negative infinity, since that is not a real number. So we're just going to replace negative infinity with a really, really small number. The notation you see here is purely calculator notation. Please don't ever answer like that on a test. You can write that down as an example to show your work, but you would never actually write the E notation. So what this means, 1E99, means negative 1 times 10 to the power of 99. Okay, so some really, really small number. So those are the same.